Hello guys, today we're going to talk about the IC circuit and also about the switches, how we connect them and how to use them. Here we have a couple of ICs. So the first thing that we need to do with the IC when we have an IC in our hand is to determine where is the little notch, and always put it on the left side. This little notch or half circle or the U shape, it's on my left side right now where it should be. This is important because it's tell us where is the beginning and the ending of each IC. Then we read the numbers on the IC. Here we're gonna see the SN74LS04N. What we care about is the last two digits, the 04. Next thing we need to look about is the datasheet. Before we look into that, remember this little notch, the U shape. The U, usually when we write it in the alphabetic words, is from left to right, or from left and then down and then to the top right. So same thing with the pins. This is pin 1 and then goes down to pin 2, 3, 4, all the way down to pin 7. And then we go up from pin 8, 9, 10, and then up all the way up to the pin number 14. So that's why this little edge or notch or U shape is really important. Now with that being said, let's agree that we're gonna plug each IC that we have with the little notch to the left side. So that way it's gonna be easy for us to determine where we start and end. Next thing is we need to determine if that IC is good or not. We're gonna look at the pins and make sure that it is none of them is broken. So as we can see here, to the first one on the left, it is broken, so that's why we're not able to use it. In the experiment, we're gonna use the 04 and also the 08, and last IC that we're gonna use is the 32. Now, in order to put the IC on the breadboard, we agreed that we're gonna put the little notch on the left. So we're gonna use the last row from the first section on the breadboard and the first row from the bottom section on the breadboard. Please don't use the second or the third row because that will ruin the pins. The IC should go on the last row, row number F from your breadboard, and row name E with the letter E from the breadboard. Okay, so here we go for the second IC and also the third IC. Now, if we want to use the first pin, remember that the full column is connected. So any point from here will be connected to the first pin, and the same for the other pins. Now, you remember that we talk about the two numbers. Now, as you can see, I just typed the name and then datasheet with it. Then we're gonna click enter on the first page. Then we're gonna go to the PDF file, anyone, click on the name, click on download, then scroll down till we found the datasheet. The datasheet is just a schematic circuit diagram for what actually inside that IC, or how the pin are mapped inside that IC. This is what we need. We have this on our lab manual. Now, as I said, we have this datasheet in our lab manual for the chips that we're gonna use. If you don't, you could use the internet. Now, this is the picture that we do have from the lab manual. What we care about is, first of all, the little notch. And then we're going to determine where is the VCC and also where is the ground. With that being said, then we're gonna let me use different color, and then let's decide where is the inputs. So pin number 1 is an input, pin number 3 an input, pin number 5 as an input, and all the way to pin 13, 11, 9. All of these are inputs. Now, what about the outputs? For pin number 1 as an input, pin 2 is an output. If I use the first circuit, so the first inverter, then I have to use pin number 1 as an input, pin number 2 as an output. Same for the second one. 3 is an input, 4 is an output. If I use 11 as an input, then 10 is an output. And the same for the rest. Um, Remember that you cannot swap the pin number 14 with pin number 7. Those are very important. If we plug them to the incorrect, or if we swap the positive with the negative, we might ruin the IC. Same thing for the other ICs, but keep in mind that for the other ICs like the 08 and the 32, the AND gate and the OR gate, we have two inputs for each circuit. For example, pin 4 and pin 5 is an input and pin 6 is an output, right? Again, guys, what we really care about is the VCC for each IC in the ground. They are pretty sensitive, we don't want to ruin them. Now keep in mind that A is represent the 7 for LS04 and B represent the 08, which is the AND gate, and C represent the 32, which is the OR gate. Now let's talk about switches. What we need to know is where it says open or where it says off. Here we have the open beneath the switch. It's really depend on the manufacturer if they're gonna put open or if they're gonna put off and then arrow. So with that being said, right now the switch number 4, and now all of them is open, so that's mean no connectivity between the upper pin and then the lower pin. So this is really important if we would like to know if the switch is off. The way we plug the switch is the same way that we plug the IC on the breadboard. The switch is used to make a connection or disconnection between the upper section and the lower section. So here I have the switch on pin number 5. So when the switch is open, that means there is no connection between the upper section of pin number 5 and lower section. Now, in such a circuit, A plus B equals C, in reality, we have for each input, we have a switch to control that input. So as many inputs we do have in the circuit, as many switches that we need for the same circuit in order to control the inputs. The reason for using the switches is, remember when we used to draw the truth table? We have number of zeros as an inputs and number of ones. How we control the inputs is for zeros and ones. The 0 represent an open switch or off switch, and the 1 represent a closed switch or an on switch, right? So this is the function of the switch. Let me write this one down also, and that's it. Thanks for watching, guys. That's it for this video.